Well, question number 1 was all about fractions. Question 1a was adding fractions. So if you've got 2 and 2/5 plus 3 and 2/3, the first thing to do would be to change it into a top-heavy fraction. 2 times 5 plus 2 is 12 over 5. 3 times 3 is 9 plus 2 is 11 over 3. And then use your smile and a kiss. Smile for the bottom, 5 times 3 is 15. And then your kiss, 12 times 3 is 36. 5 times 11 is 55. This gives you 91 over 15, which is 6 and 1/15. 15 goes into 96 times, and there's 1 left over, 1/15. The same method for question number 2 for taking away fractions is 5 minus 3 and 2/5. You can change the 5 into a fraction, saying 5 over 1. Then you're subtracting 3 times 5 plus 2 is 17 over 5. Then your smile and a kiss. The bottom is going to be 5. The top, 25. Take away 17. 8/5, which is 1 and 3/5. 1c, you're going to multiply fractions here. So again, if you change them into a top-heavy fraction, you've got 16/3 times 15 over 4. And if you multiply the top two, you get 240. If you multiply the bottom two, you get 12. 240 divided by 12 gives you 20. So when multiplying, you're multiplying the top two, multiplying the bottom two. For 1d, I'm dividing fractions this time. We change into a top-heavy fraction. 7 times 2 plus 1 is 15/2. 1 times 7 plus 3 is 10 over 7. If we're dividing the fractions, you can flip the second one and then multiply. So you've got 15 times 7 is 105. 2 times 10 is 20. That's 5 and 5/20. 20 goes into 105 5 times with 5 left over, 5/20. And 5/20 can simplify to become a quarter. Question number 2 is all about compound interest. So Rachel bought a car for £8,500. The value of the car decreased by 7% per annum for 4 years when she sold it. How much did she sell the car for? Well, you've got 100 take away 7%, that's 93% left. So you're going to have 8,500 times 0.93, that's your multiplier. Now, if it's going down in value, this will always be less than 1. If it's going up in value, this will always be more than 1. So you've got 0.93 to the power of 4, and the marks are allocated 1, 2, and 3 for the correct answer, rounded to 2 decimal places. Okay. Question number 3 is about vectors. When you're dealing with vectors, it tells you in the question that S is 3 along and 3 up, T is 5 along and 1 up, U is 2 along and 4 up, and V is 5 along and 3 up. So S is 3 and 3 along, 3 up, T is 5 along, 1 up, and you've got to draw them nose to tail with the arrows pointing in the same direction, and then your resultant vector is going to be from start to finish. In other words, it's an equivalent of S plus T is S and T together. Okay, when you've got 2T plus U, it's twice as long as what T is in the question. So instead of being 5 along, 1 up, it's going to be 10 along and 2 up. Then you're adding on your U. Again, the arrows are pointing in the same direction, as if it's going in the same journey, and your resultant vector is going to be from the start to the finish. Question 3c, I've got V minus 3S. So there's my V, it's 5 along and 3 up. 3S is 3 diagonal, if you like, it's 3 along, 3 up, but if it's minus 3S, it's going to go in the different direction. It's going to go 3 along, 3 down, 3 along, 3 down, 3 along, 3 down, because it's 3 times as big. And your resultant vector is going to be from here to here, and it's going to be in that direction. If you can imagine the size of the vector pushing here is going to overcome this force here, so it would come in this direction there. Minus U plus 2V. So there's the opposite of U, it's going in a different direction. And then I'm adding on my 2V, so again I'm drawing them nose to tail. And there's my resultant vector, minus U plus 2V. Question number 4. A boat sailed south from the port to the island of Raasay for a distance of 63 kilometres. Well, there it is, I've drawn it here. Then it's going in a bearing of 60 degrees from the north to where the boat is now, and that is 72 kilometres from the port. Now, it's asking you to find out this bearing here. In order for you to know what this bearing here is, you would need to know what this angle is. So, can we find out what this angle is? Well, no we can't. And in fact, if we go to the formula sheet and have a look at the formula sheet, you'll see that when I'm dealing with my triangles, am I dealing with area? No. Have I got all three sides? No, I don't. Have I got two sides in the included angle? No, I don't. So this is the thing that's left. And because I'm trying to find an angle, I can actually write this down upside down. So I can write it like this. Sine B over B, sine P over P, that is a P, honest, and sine R over R. So I don't need the P because I don't have either the angle or the side. But what I can do is I can rearrange this here. So sine B, this angle here, over this distance here, is going to be the same as sine R over R. So 60 over, sine 60 over 72. And then I can rearrange it. So sine B would be B times sine R over R. If I substitute in the numbers, it's 63 sine 60 over 72. It gives me a decimal. When I press shift sign of this decimal, it gives me an angle of 49.3. So I've just found out this angle in here is 49.3. Now for me to find out this angle, I need to know that all the three angles in a triangle add up to 180. So if I add these two up and then take them away from 180, that gives me 70.7 for this angle in here. And if I take that away from 180, I end up with 109 degrees to the nearest degree, or a bearing of 109 to the nearest degree. It does ask me for the nearest degree in the question, so I would have to round it in order to get all 4 of the marks. Okay, so the marks are allocated. A couple of marks for this bit here. You get a mark for getting this one, and you get a mark also for getting the bearing correct to 1 decimal place. Question number 5. To bring it over. Question number 5 is about a tank that's leaking. Okay, so there's the tank. It's a straight line question. Hopefully you noticed that straight away. Now the thing you need to know about straight line questions is, do you have, where it cuts the y-axis, do you have the gradient? No, but you can work the gradient out pretty easily. The gradient is going to be negative, and it's going to be the vertical distance over the horizontal distance, which is 100 over 150, which is minus 2/3. Now, if you said that point here is 0, 100, this point here is 150, 0, and you put it into the m equals y2, take y1 over x2, take x1, you will also get the same answer out here. That's absolutely fine. I've just done a wee bit of a shortcut because it's vertical over horizontal. So it's minus 2/3 for the gradient, because it's going down from left to right, that's what makes it minus, and it cuts at 100. So I can then put it into this y equals mx plus c. So I can put it into this equation here. There's my gradient, m, and there's c, where it cuts the y-axis. Now, I'm not quite finished because the question asked me to do it in terms of v and t. So instead of y, I'm going to have v. I'm going to have minus 2/3 t plus 100. So I would have to put it into that form in order to get all the marks with the v and t. Next, question B, it says, how many minutes does it take for the container to lose 30 litres of water? So if it's losing 30 litres of water, that means it would take it to 70. So if the volume is 70, then I'm replacing the volume, the V with the volume, and I want to find out what T is. So V equals minus 2/3 T plus 100. If I take away 100 from both sides, I get minus 30 is minus 2/3 T. And then I can multiply both sides by 3, divide by minus 2, and I end up with the time being 45 seconds by the time it gets to roughly around about here, when it's lost 30 litres from the tank. Question number 6. I've got to solve this inequation. An inequation is very similar to an equation, except that instead of an equal sign, I've got less than, more than, less than or equal to, or more than or equal to. And I just treat it like an equal sign. I keep it the same. I want all the p's on one side, I want all the numbers on the other side. So the first of all, if I take away p from both sides, I end up with 15 minus 3p this time is less than 3. If I take away 15 from both sides, I get minus 3p is less than minus 12. And if I divide both sides by minus 3, I end up with p is greater than 4. Now notice that this symbol switched round. And that's because if you divide by a negative, this symbol will change direction. And that's the key thing that you've got to remember. It's the main difference between inequations and equations, except of course there's a different sort of equal sign because it's an inequality rather than an equal. Okay, question number 7. I've got to rearrange this equation in terms of x. So first of all, I can write it the other way around if I want to, and I can take away u from both sides, and I end up with 2ax is equal to v squared minus u squared. Then I can divide both by 2a, and I end up with x equals v squared minus u squared all over 2a. Now, question number 8 is a quadratic. Now, if you were asked to sketch the quadratic, sometimes you would have it in this form here, where you have ax squared plus bx plus c, and then you can factorise it if you want to. This has been already factorised for you, and what you need to do is you need to find the key points so that you're able to sketch this graph. Now, the first thing you need to recognise is that when we're crossing the x-axis, the y value is 0. So if the y value is 1, y value is minus 1, when it's crossing the x-axis, the y value is 0. So that means I'm going to equate this to 0, y equals 0. So if that's 0, the only way that you can get 0 as a product is if one of these two things is equal to 0. So either x minus 4 is equal to 0, in which case x would be 4, or x plus 2 equals 0, where x would be minus 2. So I've just found out the two roots of the equation where it crosses the x-axis. Next, I've got to find out where it crosses the y-axis, and this time the x value is going to be 0. If that's 1, that's minus 1, this is 0. So if I substitute in x is 0, I can substitute into the quadratic in any form. This one is going to be 0 minus 4 times 0 plus 2. It's minus 4 times 2, which is minus 8, and it gives me the coordinate here, 0 minus 8. It's important I write the coordinates in as well. For the turning point, I should recognise that this is symmetrical. Halfway between minus 2 and 4 is going to be 1. If I substitute x as 1 into this equation, I can then find out that the y value, the corresponding y coordinate, would be minus 9. So the turning point is 1 minus 9. Maybe can't see that very clearly there. 1 minus 9. And you can tell that it's a minimum turning point because it's the furthest down that it goes is here. So that's a minimum turning point. A maximum turning point is that upside down. Okay, question number 9, it says a parabola has this equation here. Write down the equation of the axis of symmetry. So the equation of the axis of symmetry is when you have a quadratic like this, the axis of symmetry is the line that would go straight up and down. Now, any line that goes straight up and down is going to be x equals something. And it's going to be the x value that shares the turning point. So you should know when you have it in this form here, the completed square form, the turning point will be 3 minus 4, and you should know that the equation of the axis of symmetry would be x equals 3. So that would be the equation of that line going up and down there. So you don't need to draw it, it just asks you what it is, it's x equals 3. For B, it's a minimum turning point because this x squared is positive, so that means it's a positive happy face, and the turning point is going to be 3 minus 4. Remember, it's always the opposite symbol of what's in here. Okay? And it's 1 mark for this, 1 mark for getting the equation of the axis of symmetry correct, 1 mark for knowing it's a minimum, and 1 mark for each of the coordinates in the turning point. Question number 10, it says solve this equation here. It is worth 4 marks, so it's likely to be a wee bit trickier than just a straightforward factorisation. Now, you're factorising priorities, that's the order in which you do something. First of all, remove the highest common factor, there's none. Secondly, look for a difference of 2 squares, there's none. Thirdly, can you factorise it? 2 times minus 4 is minus 8. Are there any factors of minus 8 that add up to 3? That add up to positive 3? No, there isn't. So when you do this into, but you then use a quadratic formula, which is your next protocol and your priorities. So highest common factor, difference of two squares, trinomial, quadratic formula, and it's given to you at the front of the exam. So just copy it down very carefully. Remember the minus at the start. Remember the way it goes round, and then you're substituting in the values where this is A, this is B, this is C. And you get to this stage here where you've got minus 3 plus root 41 over 4, or minus 3 minus root 41 over 4. And that gives you an x value of 0.85 or minus 2.35. And that's your two different options. So that's your 4 marks. Your 4 marks being for substituting incorrectly, for getting to this point here, and for having these 2 points. Question number 11, we have got this here. It says it has one root. Now, this, because it's telling you that it has one root, you should know about the discriminant. This thing here in the quadratic formula is a discriminant. Now, the reason this works is because if this is a positive value, then you get two different answers. If this is 0, then you would only have one answer, because minus 3 plus 0 or minus 3 take away 0, it would give you the same answer. So you only have one real root. Or the roots are the same. The roots are real and the same. If you have a minus value